Bismillah ar-Rahman ar-Rahim. So we started talking about transport layer security. We talked about TLS. There was one issue that was raised last lecture regarding the length of the compressed payload. And we said that the length is actually stored in the TLS record header. And since this one is not, it's actually exposed, it's not encrypted. This can reveal if the padding length is part of this. The padding length is not part of the header. So what happens is that this compressed length is the length of the entire payload, including even the MAC. So when I look deeply at the standard, this compressed length refers to the entire length of the payload, including the MAC, and including the padding, and including the padding length. So the padding length is actually, so the MAC itself is fixed length. We know that, right? So the last byte here is the padding length. It's actually 1 byte. So it can be from 0 to 255. So that refers to the padding length, and then this refers to this is the padding, which can be up to 255 bytes. Okay, so that's how the standard. So everything is, all of this is actually encrypted. All of this is encrypted, including the padding length. And as we will see in SSH today, SSH using similar concept, but except that the padding length is at the beginning of the packet, not at the end. We'll talk about this. These are slight differences between the standards, but definitely the padding length and the padding itself is part of the encrypted. It's not to be exposed, of course, which means that it's not exposed. Okay, so today, inshallah, we need to talk about. Okay, so today, inshallah, we need to talk about SSH. So, as we said, TLS was originally designed for client-server, particularly working hand-in-hand with HTTP, except that, again, it was actually expanded to be utilized in other services other than even HTTP. Similarly, SSH. Originally, SSH was designed with the perception of trying to replace Telnet. The original purpose was to try to augment Telnet, because Telnet was unsecure, totally unsecure. Which means Telnet is used for what? For remote login, right? So you can log on to a server, and you can control that server. You can download files, upload files, things like that. So everything was exposed. So the original Telnet protocol was unsecured, which means that even your password is exposed. Even when you log on, everything is exposed. The channel is exposed. So SSH was designed to augment Telnet or to replace Telnet with a secure protocol, basically. It's meant to be very lightweight. It's meant to be very lightweight, and it's used mainly to control a server using a secure connection rather than using Telnet. So with that perception, there is one fundamental difference that we talked about last time, because when we talk about the time span for, this is the time, okay? TLS uses one, of course, long session, and by session we mean that this is TLS, which works hand in hand with HTTP in the same level, in the same session level like HTTP. And by session here, we mean accumulation of conversation between a client and a server. TLS works on top of TCP, so we would assume that we have short-term connections, sometimes sequential, and sometimes they are parallel. Okay? So TLS came with the record protocol that adds, on top of this, it adds the tunnels. So each of these connections, they will work inside the tunnel, and each of these tunnels, they use the TLS connection state. TLS connection state is instantiated from the cipher spec, which is part of the session. Okay, the cipher spec or the TLS session is negotiated through the handshake protocol that we talked about last time. And using this cipher spec, we can instantiate multiple TLS connections, which is one-to-many. Okay, so each TLS connection state would contain all the keys required for a encryption, integrity, everything. Okay, that's how TLS works. SSH is slightly different. SSH uses one long-term connection, okay, which is used for the entire session. It's actually one long-term connection per session. So it's actually one-to-one. Okay? And the idea, again, is to make it very lightweight. It's one connection used from beginning to end. However, like Telnet and SSH and all these services, you have to, when you log on and you try to control the server, you may actually download 100 files, upload 100 files, things like that. So, and as we might notice, is that these files, they get downloaded in parallel. So how does it do that? It actually performs this not through multiple connections. No, it has defined a new concept called channels. So these channels, so if you talk about, of course, the secure SSH, of course, naturally we have one big tunnel, okay, which means that we have one cipher spec for the entire connection. From the cipher spec, we have to instantiate all the keys, and these keys will be used throughout the entire connection. It's one connection, okay? But inside these connections, we can multiplex multiple channels. There's a difference, there is a huge difference between channel and a connection. Okay? In the channel, you don't have like a separate channel state. You don't have a separate connection. Channel is like a one stream, logical stream, inside the connection. Okay? So the overhead for channels is much less compared to maintaining multiple connections. We'll talk about this later in more details. But the main idea here is that unlike TLS, SSH uses one long-term connection. The main objective of SSH is to be used for remote login. However, now we're using SSH for secure FTP and other things. So like TLS, also SSH proliferated to be used with other services other than just remote login. Okay, but the main idea here, this is one big difference, is that SSH is lighter in terms of complexity. It maintains only one long-term connection, and it uses the separate downloads and uploads using the concept of channels, which is a logical stream rather than separate connection. Okay, so this is in a nutshell. يعني طبعا احنا we'll talk in more details. Okay. Oops. تفضلي يا ريت.
Are there any benefits of using multiple connections compared to multiple?
Yes, we'll talk about that. We'll talk about there is a benefit. We'll talk about this. So SSH client and server applications are widely available for most operations, has become the method for choice for X-tunneling. We'll talk about the services that SSH provides, including X-tunneling, which provides geographical user interface, which is what we use for Ubuntu and things like that. So you can have remote login, not just by a command line, but you can have a graphical user interface. Everything is running on the server, but you have a graphical user interface that allows you to interact with the server. So not just command line. And is rapidly becoming one and most pervasive applications. We'll talk about also port forwarding, which is one of the very, very key, and this is unique service actually as part of SSH, which is not provided by TLS. We'll talk about the port forwarding and why is it so widely used, and it's useful really. Type like also TLS, SSH2 fixes some number of flaws, and when we talk about flaws here, we don't necessarily talk about problems with with the mechanism. Again, the mechanism itself is good. It's just that some of the flaws in the protocol handshaking, some of which tries to fix some problems that will create some attack surface as part of the protocol handshake. And in other cases, we try to make it faster. We try to make the instantiation of or the handshake faster compared to version 1. ماشي? And as we said, SSH also provides more general client-server capability, which can be used for secure FTP and other services, so similar to TLS. So this is the protocol stack. There are some similarities with TLS, of course. So we see that this is a SSH transport layer protocol, which works on top of TCP. So that corresponds to which protocol in TLS? تفكر? You will have to remember because we're 2 weeks away or 3 weeks away from the exam. So with TLS, we talked about a portfolio of protocol. In the transport layer, we talked about how we established the tunnel for TLS, and we used the record protocol. The record protocol was the one that's used in the transport level. And there are services or protocols used in the session level. This is in the session level. So here where HTTP is in case of TLS. Here, in that particular case, we have two services. One of them is user authentication. So user authentication for SSH, it's a separate service at the session level, unlike TLS, because for TLS, both the client and the server, okay, they authenticate to each other at the handshake level. But here, the server authentication happens in the transport layer protocol, and we'll talk about this. So the server has to authenticate itself to the client as part of the transport layer protocol, and that's also a significant difference. So in TLS, both the authentication between the server and the client, they happen at the session level as part of the handshake protocol, which was in the session level. Here, the authentication for the server has to happen as part of the transport layer protocol. And only the user authentication happens at the session level. And why is that? This is because of the fact that this is used for remote login, right? So when you try to connect to a remote server using Telnet or using SSH, what happens is that once you connect to the server has to authenticate itself to the user and then presents the login credentials to the user. So you have to log in, right? Whether on Ubuntu, graphically, or whatever, right? Once you get this prompt, this means that the entire connection with the tunnel have been established already. So in order to start the establishment of this tunnel, the server has to authenticate itself to the client and then presents the user authentication as a service to the user, okay? User has to log on either using user ID and password or using certificates, or we'll talk about this, right? But at this point, all the connection, all the tunneling has been established already. So we'll see that, okay? The other service here, which is for channel multiplexing, for how to manage the channels. We talked about the concept of channels, which does not exist in TLS. Here, we talk about the channel management, which means that we need to create, instantiate, and multiplex the channels, which can be used to download or upload multiple files. Of course, there's one channel which is used for command control, right? So this is one command channel which is used for command control. But then if you say, get مثلا 100 files, right? So there are multiple channels that get created to download all the 100 files at the same time. So, okay, so we'll talk about all of this. All right, so this is the protocol stack. So as we said, server authentication occurs at the transport layer, and that's one also major difference. Why we want to do this? Because we want to establish everything before the user starts to log in. We want to establish the connection and the tunneling before the user starts to log in, based on the server processing in public and private key. So the server uses one method for authentication with the client, which is to present the certificate. So the client has to receive the certificate from the user, and that happens at the transport layer level. A server may have multiple host keys using multiple different asymmetric encryption algorithm. Why does the server need to have multiple private keys? Of course, because it may actually provide multiple services and things like that. So it may actually have multiple public keys, which can be presented to different set of users. Okay, so how does the client manages these certificates from multiple servers? So we have the client here, and we have multiple potential SSH servers. Okay, so this is server 1, server 2, server 3, server 4, and server 5. Each of these servers, they may have one or more public keys or certificates, basically. Okay, so when the client tries to connect to one of these servers, it has to establish the trust. So the server sends the certificate to the client. So the client in that case may actually store these certificates locally. Okay, so whenever it connects to a server, the server presents its certificate once, and it may actually store it in a cache. This is one method. The other method, which is we establish the trust through a certificate authority, this method here. Okay, so the certificate authority maintains the certificates of all these servers, and the client connects to the certificate authority to establish some trust with the different servers. Or you may actually combine the two methods. So you can establish trust directly to the server and download the certificates. In all cases, whatever certificates you download, you may actually keep in the cache, so that when you try to connect to the same server again, you can agree on the same certificate, and then the trust will be established directly. Okay, so to optimize the performance, the client may in fact use some local cache to optimize this process. So the client has a local database that associates each host name with a corresponding public host key. Okay, or the host name to key association is certified using a certificate authority. So these are the two possible methods. Either you establish the trust directly with the server and download, and you have a local database or a local cache that maintains all these certificates, or you can establish this trust through a certificate authority, which is based on the change certificate that we talked about before, if you remember. So these are the two possible methods. يعني. ماشي? طبعا, of course, needless to say that each server serves multiple clients, right? So this process that we talked about happens at every client, right? So this is basically the transport protocol, which facilitates the handshake. Of course, it starts with the establishment of the TCP connection, and it's, as we said, it's one connection. Here, it's simply one connection. So when we establish the TCP connection, if you remember from network 1, it starts from the client sending a message. حد فاكر المسج اللي هي اسمها ايه؟ لا هي for TCP. احنا هنا we're talking about TCP. Hello comes later. هنا TCP it sends a message called send or synchron. فاكرين حاجات okay. And then the server would send acknowledgement and another send, right? They synchronize, and then the client would send the acknowledgement for the send message coming from the server. So this is we call it three-way handshake. So this connection happens at the beginning. This is what this phase talks about, right? And then similar to TLS, more or less, here we send the versions. The client here sends the version, اللي هي ال SSH protocol version. ممكن the message is like this, it's SSH1 or SSH2. And then the software version. Software version is what? You use what software to implement the SSH? PATI مثلا. You know the PATI software. PATI can be used for SSH client. So in that case, it would be مثلا PATI 1.0, something like that. So that's the typical message. So the server then responds back with the same version, which means that we agree on this version, or a different version, maybe lower, maybe higher, things like that. If the server responds back that I don't support this version, then the communication stops at this point. Okay? This is بقى where the hello message comes in. So the client, in that case, negotiates the algorithms. So it sends here all the parameters and all the algorithms that it needs to use for key exchange, for authentication, for compression, for encryption. Okay? So it has to send all the parameters for all of this as part of this message. Okay? And then the server has to send the hello message back. And here, where the server authentication happens, as part of the key exchange here. So here, key exchange and server authentication happens. By key exchange here, I mean for Diffie-Hellman, when we send the parameters, we send back a public key, and then we have to exchange the symmetric key on both sides. And as part of this, the server authentication has to happen, which means that the server has to authenticate itself to the client. Okay? Once we do this message is similar to change cipher spec, which means that, okay, we have finished everything. Then what we do is that we build a hash. Unlike TLS, in SSH, remember in TLS we used to, the server and the client, they used to exchange what we call random sequence, right? Here, what happens is that the server and the client independently, they generate a hash based on all the messages that have been exchanged. And this hash will be generated on both sides. So at this point, I have a pre-master key, and I have a hash. Okay? The hash is based on all the messages that have been exchanged, and the pre-master key, which is exchanged as part of the key exchange, like Diffie-Hellman. Okay? So both the server and the client, they have now a pre-master key, and they have a hash. And the server has authenticated itself to the client, which is a requirement as part of this transport protocol. The server must actually authenticate itself to the client using certificates. This is the only method which is used as part of SSH. ماشي؟ تمام كده؟ So here we have a pre-master key and we have a hash. Based on the pre-master key, the exchange key, and the hash, with some other information which is not really very important, يعني, including session ID, and these are fixed letters and things like that. We generate all the keys, and again here, we don't have a separate connection state and a session state. We don't have this. It's actually one connection, right? So we have the same cipher spec for the entire connection. It's one connection. هي ما فيش غيرها. هي one connection. Okay? And even the channels, they don't maintain a separate security context. And this is by design. It's meant to be lightweight. So channels are only logical streams inside the same tunnel. They do not maintain a separate security context. واضحة دي? Okay? So that's it. So based on the pre-master key and the hash, right? We generate all the keys for IV, اللي هو initial vectors, for encryption and for integrity. The same 6 keys we generated for TLS for every single connection in the case of TLS. Here it's only one connection. That's why this generation process is only one time and that's it. واضح كده? Any questions so far? Hmm?
What are the letters ABs?
These are arbitrary letters which is used just for the generation of these keys. يعني. And there is like session ID, and there are some other parameters, by the way, which is detailed in the standard. But as I said, they are not very important. يعني. مثلا يعني timestamp, there is specific other parameters. We don't have to really worry about them. يعني. The most important thing is the key. It's a symmetric key, of course, or a pre-master key, and the hash. And there is no details in the standard that مثلا this pre-master key will have different sizes because it's one method for authentication, at least by the server, which is the certificate. So the expected size for the pre-master key is fixed, in which case we don't have to use the pre-master key to generate another permanent key or something. So they just use the generated pre-master key directly to generate all these set of keys. And they generate it once and for all for the entire session because it's only one connection. ماشي كده؟ طيب. This is the protocol data unit. And as we can see, طبعا sequence number here is used for replay attack. تمام. It's only one because again we're working on top of TCP, so there is no need for يعني window or something like this. It's only one sequence number. So here we have the packet length and we have the padding length. So the slight difference here is that the padding length is before the compressed payload. طبعا compression is optional, similar to TLS. ماشي? This is obvious. So the only difference here is that the padding length is at the beginning, but in any case, everything is encrypted, right? So the padding length and the packet lengths are encrypted anyway. So they are not exposed, right? But the slight difference, the other slight difference here is that if you look at TLS, you will see that the encryption is done after MAC. Here, MAC is done after the encryption. As we said before, there's no preference one way or another. ماشي? There's no consistency or there's no consistent theory that says that you have to do MAC before encryption or encryption before MAC. There's no distinction. So here they do encryption first, okay, and then the MAC is separate. In TLS, the encryption is done after MAC, which means that MAC is encrypted as part of the MAC itself is encrypted as part of the encrypted payload. Okay, any questions? So this is the protocol data. Again, it's simpler, and there's no different format for different protocols. Like in the case of TLS, we had different types of payloads because we had the alert protocol. Here, there's no mention of the alert protocol or anything like this. It's meant to be very lightweight. So these are the set of protocols or mechanisms that can be used for the different aspects of security, so including the cipher for encryption. So the green ones are the ones that are mandatory to be part of the implementation. So if your implementation does not support these green ones, this means that you're not compliant with the standard in any way. Okay, so these green ones are core, are mandatory, that has to be part of the implementation. The white ones are optional. So if if your implementation does not include these white ones, that's fine. You can still comply with the standard. So this is for the encryption. So for encryption, for example, you have to have triple DES and you have to have AES 128. These are the minimum ones that you need to have. For Mac, you need to have HMAC SHA-1 or HMAC SHA-196 or whatever. And compression, of course, is optional. So even if you don't have compression, you still comply with the standard. ماشي? So these are, طبعا, of course, there are tons of other mechanisms and algorithms for other aspects, but they are detailed in the standard. So now when it comes to user authentication, because server authentication is already done. For user authentication here, there are 3 methods for user authentication. We have the public key, so the client, instead of presenting user ID and password or something like this, the application itself may provide a public key or send back to the server a certificate. So in the PATI مثلا configuration, you don't have to provide user ID and password per se. You can just provide a public key. And that's the way that the user authenticates itself to the server. Server is already authenticated, and we're talking about from the user to the layer as part of the authentication user service, which is part of the session level. So the client sends a message to the server that contains the client's public key of the application. When the server receives this message, it checks whether the supplied key is acceptable for authentication. If so, it checks whether the signature is correct, and then it authenticates the user. So that's one method. Another method is the user ID and password. So the client will send a message containing a plain text password. How come? How can the user sends the password in plain text? Is that really secure?
Because the communication is secure.
أيوة بالضبط. Just the fact that the client presents the plain text of the password, that doesn't mean that the password will be transferred in plain text, because remember here, the tunnel has been established already. And that's why the user authentication is actually a service on top of the tunnel that's already established. So anything, even if you present your password in plain text, it will go through the tunnel and it will be encrypted. ماشي? This is unlike مثلا in Kerberos, we cannot send the password in plain text. So what we do is that instead we send the server will send a puzzle based on the password, and then the client has to solve the puzzle and so on and so forth. Here we don't have to do that because we already have an established secure tunnel. So anything that goes through the tunnel will in fact be encrypted anyway. So the user presents the user ID and password, okay, and it gets encrypted as part of the tunnel already. ماشي? The third method here is host-based public key. So here, authentication is performed on the client's host rather than the client itself. Client host معناه إيه? This is a public key which is built in the host itself, which means that it's part of the operating system. It's not within PATI بقى. It's actually a public key in Windows. Okay? So the whole host uses the certificate in the operating system to authenticate itself to the SSH server. So the slight difference between this method and this is that this public key is built into the software client, which is مثلا PATI ولا حاجة زي كده. Here, it's actually built in Windows. This is the host public key, not the application public key or not the client's public key. ماشي. So rather than directly verifying the user's identity, the SSH verifies the identity of the client host itself, not the client software, not the client party or something. ماشي كده. So these are the three methods for, so either public key of the application or the client, public key of the host, or the password in plain text. So these are the three methods for user authentication. Type. This is about the connection protocol. The SSH connection protocol runs on top of the SSH transport layer protocol, and it assumes that the secure authentication connection is in use, which means that everything is already established and the tunnel already established, and in that case, the connection protocol may instantiate some logical streams. We call them channels, not connections, but channels. Okay. So the secure authentication connection referred to as tunnel is used by the connection protocol to multiplex number of logical channels. Logical channels. Okay. Right. Very quickly to answer your question at the beginning, يعني if you have multiple connections or if you have multiple channels, what is the difference? So if I have a client and I have a server, okay, and then I use multiple connections, multiple parallel connections to the server, okay? Each connection is used to download files. ماشي? Another way is from the same client, I can use one connection, okay, with different channels to download the same 100 files. Okay, which one is faster? What are the pros and cons basically? Yani? Which one is faster? You say this. So this is method number one. This is method number two. So you say method number two will be faster. Wrong, big wrong. Huh?
Method number one is faster.
It's fast. ليه بقى?
And we have multiple connections.
Yeah, but
It's based on the resources that the server allocates for each connection.
right. So why the server allocates more resources when the
Does
connections?
the server be allocated like based on the number of connections, not based on the number of?
يعني هو this is correct, but this comes from the يعني this is we teach this as part of advanced networks course when we talk about TCP. TCP, and this is why, for example, for peer-to-peer اللي هي زي الإيميول والحاجات دي. Why do they use more than one connection to the same server when they are trying to download even the same file? They divide the file into chunks, okay, and they create multiple connections to download different chunks. Why? Because this is faster. Because TCP tries to perform flow control, and it tries to be fair across all the existing connections. TCP performs flow control, and it tries to be fair. So if, again, this is explained in details in advanced networks, but I'll just to answer the question. So if we have a bandwidth, a shared bandwidth between this client and the server equals to B, okay, and we use TCP for all, which means that whether we use TLS or SSH, we use TCP, of course. So the underneath protocol TCP will try to be fair between all these connections, which means that the bandwidth per connection will be P over 11. So all the bandwidths of all these connections will be P over 11, which means that technically, when I use TLS, مثلا, with 10 different connections, technically, I have tapped into 10 times the throughput of SSH. Okay? That's a big advantage. صح؟ طيب. What is the drawback بقى؟ إيه الcost? Is this for free? Yeah, what is the cost? Overhead, bravo عليك, yes. So the connection management here is very high. And remember, I have TLS connection state for every single connection, right? So I have to instantiate the entire security context separately for each connection. صح? I don't have to do this here. Channels are just logical stream within the same tunnel, but here I have to establish 10 different tunnels. This is from a security perspective طبعا. طيب, from TCP perspective, each one of these will have a separate socket. Socket معناها buffer at the client, buffer at the server, and the buffer is identified by source port, destination port, source address, destination address. I have to have buffers. I have to maintain all these buffers, things like that. Okay, so the cost that I have to pay is, of course, connection management. It's a big overhead. So this is the pros and cons.
Professor, you mean the overhead of the memory and storing all this information? Or
Yeah, maintaining all these connections in parallel requires some overhead, of course. Each connection معناها I have to establish the connection, and establishing the connection معناها ايه؟ Three-way handshake, right? And when after doing the three-way handshake, I have to establish socket buffers at the client and at the server, right? And on top of this, when we talk about security, I have to establish a different security context for each of these connections, which means that set of keys, the 6 keys that we talked about, have to be established separately for each of these connections. ماشي? Of course, this is a big overhead. And the advantage here is that, as we said, I mean, we tap into more resources by having multiple connections.
but what about time?
Hmm?
The time here. What's the
Time for what? Time for establishing these connections, or time for downloading the files? For the data? لا.
whatever. The time.
لا لا. Establishing these connections, of course, requires more time. Because for each of these connections, I have to establish three-way handshake for TCP. And then I have to negotiate all the security context for each connection separately. ماشي? Here,
So number 2 is faster.
for connection establishment, yes, of course. But once the connection is established and the tunnel and the context is established, what do you use this connection for? I need to download data files from the server. Okay? Definitely method 1 will be faster. Because these connections will tap into more resources. يعني مثلا the server will think that these 10 different connections are coming from 10 different users. So it will give more resources. This is how TCP is designed. Again, to understand this, we have to go through the lesson بقى of how TCP performs flow control and how it's fair, and this requires يعني a separate lecture يعني. ماشي, but these are the pros and cons يعني.
For the first method, like in connection establishment can't be parallelized?
لا, it has to be sequential. It has to يعني TCP has to do it sequential. لازم تحصل sequential. أصل parallel through what? Not everything has to be sequential. لازم.
So this is like beneficial in case we have, like, for example, we want to download like a very large file.
Right. A very large file or multiple files. Yes, definitely. Multiple files faster يعني. For the channel mechanism here, all types of communication using SSH are supported using separate channels. Either side may open a channel. So the channel is unlike بقى ايه الconnection. Connection has to be initiated from the client all the time. But channel mechanism can be initiated because it's the same tunnel, it's the same connection. خلاص, the connection is established. Anyone can establish a channel. So for example, if a client wants to get something, then the client may actually instantiate the channel, negotiate the channel mechanism. If the server downloads anything, the server may actually initiate.
I think maybe her question was if you could parallelize each of the separate TCP connections that you have, not the TCP for one connection itself, but you have the three-way handshake for sure. But I think her question was more about if you could parallelize each of these connections.
لا parallelize the connection, of course, in terms of data transfer طبعا this goes in parallel, but parallelize the connection instantiation or the connection creation, that cannot happen. The three-way handshake has to happen sequentially. Once the three-way handshake is done and the connection is established, you can definitely create multiple of these connections, okay? Once the connections are established already, then the transfer may happen parallel, طبعا, definitely. Why? Because each of these connections will run in a separate socket. We'll have separate sockets, okay? So channels are flow controlled using a window mechanism. So channels, they use بقى ايه application level flow control, not the TCP flow control. ماشي؟ يعني برضو there is some kind of flow control within the channel, but that does not require the server to give more resources. No, because this is application level flow control. It's not TCP flow control. It's not transport layer flow control. So no data may be sent a channel until a message is received to indicate that the window space is available. طبعا this is part of flow control. ماشي? And the life of a channel progress through 3 stages: opening a channel, transfer data, and then closing the channel. This is how it looks like. This is for the A. So after we instantiate the transport layer connection and the and the transport tunnel is done, the client may actually send a channel open. Then the server sends confirmation that the server accepts the channel, and then transfer of data happens from the server or from the client, it doesn't matter. And then at the end, we close the channel. So opening the channel, sending data, close channel. Okay?
Is there a limit on how many channels you have?
Not that I know of in the standard, no, not that I know of, no. No. Everything has a limit, of course. Of course, the more channels you have, the less the throughput will be per channel, yeah. It's not always advisable that you have 1,000 channels open. So I think in the standard there's no mention for this because it's left up to the server implementation. So the server may, in fact, restrict the number of channels. It's pre-configured, مثلا, in the server. But in the standard, there's no limit because it's based on the resources available at the server. Some server may allow up to 1,000 channels. Some servers might allow 1 million, depending on the resources. Okay. طيب. So what are the different channel types? We talked about these channels, right? The concept of logical channels. What are these channel types? So 4 types of channels are recognized by the connection protocol specification. There is the session or the remote execution of a program. So there is one main channel which is used for command control. Okay, so one main channel which is used for command control. So when you do remote login to a server, you control the server using commands. So this is the main channel where the user presents his credentials or his authentication method and then starts to interact with the server based on commands. You can use also X11, which provides graphical user interface interaction. So not only by a command line, but graphical user interface connection. Okay. There are about 2 other channel types. These are very important. These are unique for SSH. They did not exist at all for TLS. TLS did not provide these services at all, which is called port forwarding. Okay, to understand about port forwarding and why is it this is particularly useful service in SSH, which is يعني until recently it was very, very commonly used. So this provides VPN-like service, but this port forwarding is slightly different. So let's imagine we have this scenario. So you have a client or a host. Let's call it a host, not necessarily a client. And this host wants to access a restricted website using HTTP, not HTTPS. Because if it's HTTPS, most probably it will be fine. But I want to access an external website using HTTP. Whether this is legal, illegal, it's not our problem yet. And in many cases, this particular situation happened to many of us. If that server or host uses HTTP link, most probably it will be blocked by a firewall. Okay? So the firewall will block it. Because of several reasons, because this website is restricted, or because this website uses HTTP, which is not secure, whatever. Okay? So the normal situation here is that any request from that client to access this restricted website using HTTP, it will be blocked by the firewall. So that's one scenario. So for this, what happens here is that we can use a port forwarding from from SSH to become very, very handy in this particular situation. What happens is that here, close to the server, we will generate SSH tunnel. Okay? SSH tunnel will override بقى ال unsecure HTTP and will make it secure, right? But this is SSH, right? How we map SSH to HTTP? This is bad where we use port forwarding. So by using port forwarding, we tell SSH that there is a local port here, which is like called X, for example. Okay? If you see this local port, and by the way, this is SSH port, not TCP port. There's a slight difference here. ماشي? So SSH provide the concept of port forwarding, which creates another logical port as part of the SSH session. ماشي? When you see this local port at the end of the tunnel, map this to HTTP, whatever, and then the restricted website. Okay? So if you see this local port forwarding, this is called local port forwarding. Okay? So this way, if we create, but this requires what? This requires that we have to have SSH server here behind the firewall. Okay? So many people, they buy this as a service. So you may actually buy the service from an SSH server, مثلا in US or something like this. Similar to what we do for VPN. ماشي? This will allow you to create secure SSH tunnel that will get you through the firewall. And then use the port forwarding to say, if you see this local port, map it to HTTP restricted website. Okay? So the tunnel will allow you to go through the firewall, and then you map this local port forwarding to the HTTP restricted website. So that's one scenario, which uses what we call local port forwarding. Okay? Another scenario, which is you have a host at home, and you have a process here, okay? And this host is running over a network, a private network. Let's say, مثلا, the home network, your home network, مثلا. And this host has a private IP address, يعني 192.168, whatever. And you want to have this host to be available as a server. Can you do this using the private IP address? With the port forwarding, you can. Okay, with the port forwarding, you can. So if it's a private IP address, and of course you have a router here with the NAT, network address translation and everything, this private IP address is not exposed to the public internet, صح? So hence, you cannot easily have this running as a server, right? So you cannot have people connecting to it. Okay? So any client here wants to connect to your host, he doesn't see this private IP address at all. Okay? So in that case, also port forwarding becomes very handy. So what you could do is that from that router, or sometimes actually from the host itself, you can use the SSH tunnel. And in that case, the remote port will be mapped to the private IP address here at the beginning of the tunnel. Okay? So when the client tries to connect, it will, in fact, send to a public IP address, similar to NAT. But then when you see the remote, if the public IP address doesn't matter, but the most important thing is that the remote port has to be mapped as part of the port forwarding to the private IP address, which is not exposed to the public internet. And we'll see the configuration for both sides. So in any case, this is called local port forwarding. This is called remote port forwarding. Okay? So these are two scenarios where local port forwarding and remote port forwarding become handy as part of course, if you have access to VPN, this one is done. This one can be done easily. Okay? But this one, I'm not sure if you can do it using VPN, really. I don't think you can do it using VPN.
It's used in peer-to-peer system networks. Remote forward.
Yeah, ممكن, طبعا. So port forwarding here, one of the most useful features of SSH. It's very handy, and until recently it was very commonly used. In fact, at some point I remember a scenario where we tried to access some external servers, and it was blocked by QU. It was blocked completely by QU. Talking to ITS and going through the normal procedures took months. So I remember some people, they tried to hack by doing this. They used the local port forwarding, and they accessed an SSH server outside the university, and they created that tunnel to bypass all the security policies of ITS. I'm not encouraging you to do this at home, but this is So it provides the ability to convert any insecure TCP connection into secure SSH. So incoming TCP, of course, if that website uses HTTPS or something, most probably you can access it easily without actually having to do this. So incoming TCP traffic is delivered to the appropriate application on the basis of the port. That's what's called port forwarding. The key here is to map either the local port or the remote port to a specific URL or to an IP address and a port. And we'll see how this is done. So what you need to specify is the SSH server that you need to connect to, and whether it's local port forwarding or remote port forwarding to select one of the scenarios that we talked about. And then you specify what is the local port or what is the remote port that you need to map it. So we'll see how this is done. Any application may employ multiple port numbers. So this is how we do this. So the normal TCP connection uses a local port and a remote port. Right? So this is the local port and the remote port. So if we have a firewall here, or if we have a host here using private IP address or something like this, that's when this tunnel will try to override this process and create another level of security which allows you to use one of these two scenarios. So if you try to map this local port to a restricted website, this is local port forwarding. Okay? If you try to map the remote port to a private IP address, this is called remote port forwarding. ماشي? So remember here, the SSH ports, اللي هي ال X وال Y, these are SSH ports. These are not TCP ports. Okay? And these SSH ports, this is part of the tunnel, which means they are encrypted. SSH ports are encrypted. Okay? So these are logical ports that SSH provides to facilitate that mapping. But these ports are encrypted inside the tunnel. Okay? So nobody will see them. They are not exposed even to the telecom provider or to any firewall or something like this. ماشي? So this is the configuration. For local port forwarding, SSH client will intercept the selected application level traffic and redirect from an unsecure TCP connection to a secure SSH tunnel. Okay? On the other end, the SSH server sends incoming traffic to the destination port dedicated by the client application. So if I say this is local port forwarding, this means that I connect to this SSH example, okay? So this SSH server marks the end of the tunnel, which is supposed to be behind the firewall. ماشي? So this is where you have to connect. This marks the end of the tunnel. And then you say this is the local port. Once you see this local port, this is SSH port. Huh? Once you see this SSH port, map it to restricted website port 80, which is the HTTP, the HTTP call. Okay. Same thing happens here, except that in that case, but this is port 8080, which is the remote port, and in that case, map it to localhost. Localhost اللي هو ايه؟ اللي هو private IP address inside the private network, which is otherwise not accessible by the outside world. So by doing this, you can allow others to access your host inside the private network, even if it has a local host or any private IP address. ماشي? So this is the local port forwarding and remote port forwarding, and these two services are very, very useful as part of SSH.
Isn't remote port forwarding used by TeamViewer and applications like that?
Is it?
I think so.
Could be. I don't know.
Maybe that's the underlying
I think TeamViewer uses even more than that, because I think TeamViewer facilitates this through a third server. I don't know if it's SSH or maybe it uses HTTPS service, something like that. But it uses like a cloud-based service, and this cloud-based service acts as a mediator between the connection between the two. And it may actually perform some kind of a proxy or port forwarding as part of this process. It may actually do that. So as a summary, we talked about two different transport layer security protocols. We talked about TLS. And in the TLS, we talked about the architecture and the different protocols, whether at the session level or at the transport level, the record protocol or the handshake and alert protocol, and all of these protocols, and the heartbeat. We didn't talk about heartbeat as part of SSH. Again, it meant to be very lightweight. We didn't talk about heartbeat. We didn't talk about alert protocol. It's meant to be very lightweight and not very heavy. Yani. Even one single connection, things like that. Okay. So we also talked about the SSH secure shell transport protocol, and we talked about HTTPS using the TLS or the SSL connection. So this is the the first and the last part of this chapter, chapter 6. And last chapter بقى اللي هو chapter 11 when we talk about network intrusion and we talk about system level security, which is part 3 of the book. So we talked about the first part, which is the mechanism. We talked about the second part, which is the layer-based security protocols. And we talked about the protocols in the network access control. We talked about security protocols in the network layer, IPsec. We talked about transport layer security and so on. Chapter 11 here بقى talks about intrusion detection systems. So this is not layer specific. Here, it's not layer specific. So let's have a quick. So as we said, until this point, we talked about layer specific security protocols. So, which means that we assume that the attack happens at a certain level. So if a user tries to corrupt the network infrastructure from the network layer point of view, we have IPsec or VPN. If an attacker tries to compromise a specific application service مثلا, so we can use a security protocol, either Kerberos or TLS or SSH, to try to secure a certain application. But that does not guarantee that other applications, they have the same level of security. And that the assumption that the attack happens at a certain level is a naive assumption, really, because if an attacker wants to attack a system, as we talked in the beginning, we have an attack tree where he can, in fact, perform set of actions, okay, at different levels to facilitate that attack. So he may actually try to, مثلا, perform certain injection through the network layer and then use that to compromise a certain host. And then inside that host, he goes into that host and he tries to change some مثلا attribute of a file, to change the attribute of a file. This file مثلا contains set of, I don't know, sensitive information, things like that. And he uses that information to try to مثلا get credentials of a certain مثلا user, and then uses that credentials of that user to compromise another. And he may perform set of actions in different levels, right, to make the damage or to try to perform that attack holistically. So for these particular types of composite actions, which might happen at different levels, we have what we call intrusion detection systems. These intrusion detection systems, these are not specific security protocol that happens at a specific layer. No. These systems, the main objective of which is to try to record all the activities that are happening at the user level, as well as at the host level, as well as at the different locations of the network. And it creates what we call audit logs. You know, like very detailed and verbose audit logs, right? From these audit logs, we can monitor these audit logs, which by the way has actions in different levels, by different hosts, from different host to another host, at the network level, at the network access level, at a certain application level, things like that. So these audit logs will be analyzed holistically, because if you look at a certain layer and you look at the actions from a certain layer perspective, they might sound benign, they might sound okay. But if you take the sequence of actions in multiple levels, then this sequence of action notifies, or it may actually lead to a specific attack. ماشي? So these intrusion detection systems, they try to first log all these activities and then analyze the logs. Okay? When we analyze the logs, we talk about how do we analyze the logs. In many cases, طبعا we use as you all know, machine learning, some statistical analysis, things like that, to go through these audit logs, and from that we can deduce that there might be some suspicious behavior going on, and this suspicious behavior is maybe done by a group of users, or it's maybe done by one single user, and so on and so forth. So we have to correlate multiple actions which might happen at different levels of the network, right? So that's why it's not a layer-based technique. It's actually a system-level technique. So we'll talk about how these intrusion detection systems are designed, what are the possible methods that they use, and we'll talk about how we implement them. We can implement them using centralized way, you can implement them using distributed or decentralized way, and what is the pros and cons of these. So there are three classes of intruders. These are the possible attackers. We have the masquerader. The masquerader is the الشخص المتخفي, or يعني, and this user is an external user. This is an individual who is not authorized to use a computer, or who penetrates a system's access control to exploit legitimate users' account. So this is usually an external user to the organization. This user tries to use a certain attack surface in the organization to try to gain some unauthorized access. Okay? The misfeasor is هو الشخص الفاسد. إن هو he's an internal user بقى. So this user has a legitimate access in the organization, but he tries to abuse that access, okay, to perform certain damage in the infrastructure. So this is a legitimate user who accesses data, programs, or resources for which such access is not authorized. So he tries to use his legitimate access to gain access to an unauthorized data. And the third user is the clandestine user. Clandestine user is a user with a root access. Okay? So an individual user who seizes supervisory control of a system and uses this control to evade auditing, and يعني مثلا the admin, okay, he may actually damage بقى audit logs أصلا. He has access to everything. So if this level of user is trying to attack the system, then it becomes very, very hard to detect. So the categorization of these users like this also presents some idea about how difficult it is to detect the attack performed by each of these classes. Because usually the masquerader is very easy to detect. An external user who tries to gain access to the organization, usually this is much, much, much easier because he's an external user. Otherwise, he may have access, مثلا guest access, ولا some low privilege type of access, but he's trying to get more. So usually this type of behavior is easy to detect. But if he's a misfeasor, again, what is the motivation for a misfeasor to perform this action? What do you think is I'm a legitimate user, I'm an internal user, and I'm using my legitimate access to damage the organization. Financial, or yes, in some cases, yes. This is a very, very common scenario. A legitimate user gets terminated, مثلا, from his job or something, or her job, and they try to use the internal access to damage the infrastructure. Same thing happens for the clandestine user. So these two refer to internal users with different privileges. And the way this is classified, again, refers to the level of difficulty of how to detect the intrusion done by each of these users. This one is the hardest. Very, very hard to detect. Okay. So what are different examples for these intrusions? Performing a remote root compromise of an email server. So someone gains access to مثلا an email server and uses that email server to send مثلا fake emails or some emails to request ransom from class of users. Gains compromise to the server, then he can perform any kind of phishing email to send to everyone and try to use that to attack their emails or attack the system. Defacing a web server. So you log on to a web server, you see, okay, virus, and in order to recover the access to this web server, you need to pay ransom, something like that. So you go to a web server, and you see the web page is completely modified. It happens. Guessing and cracking passwords, unfortunately, no matter how you try to build awareness amongst users, until today, you see many users, they use very primitive passwords. And that's why, many systems, they try to restrict some policies on the passwords to have certain rules and have certain set of characters and so on and so forth. But if you don't have these policies, really, people usually tend to make it easy, and they select a password using their مثلا birth date or 1, 2, 3, 5, 6, something like that. So these are the types of passwords that can be guessed easily. Copying a database containing credit card information. There is, of course, some level of criticality for the data that you gain access to. So if we assume that we have a database with all the credit card numbers, and it happened, by the way, in one of the organizations here in Qatar at certain point, people were, some attackers, they had access to some critical information through this organization. If you have, access to credit card database, this is critical because you can use these credit cards to perform a wide impact of damage. But if you have access, for example, to patient records with some مثلا vital signs of certain patients, this is not as critical. Of course, it's privacy issue, right? But if you have access to ECG or EEG record of a patient, what is the big deal? So there is certain level of criticality also to the type of data that you gain access to. مثلا including payroll records. So viewing sensitive data like including payroll records. So again, if I know the salary of Dr. XYZ, this is not as critical as gaining access to his bank account. So also there is some criticality to the type of information that you gain access to. Running a packet sniffer on a workstation to capture user names and passwords. That's why we said sending passwords in exposed or plain text is dialing into an unsecure modem and gaining internal access to. So this is one of the attack surfaces. So this is a network access level control. So if we have a modem which is open and it does not use مثلا 802.1x, ماشي? I can use that to dial to that modem, and from that modem I can use it as an entry point to the network infrastructure, and then I start to do some network injection or something like this to the network. Posing an executive calling the help desk reset. This is some type of physical attack. So I call مثلا executive help desk and try to manipulate that help desk to reset a certain password, of an account, and then I gain access to this account, and then I use it to compromise. So that's an example. Using an unattended login workstation without permission. Also, this is some type of physical attack. A user logs in and he leaves his workstation open, so I can come in and gain access to the workstation and then use this workstation to gain access to the network. So the hackers, they attack, it can be benign. Benign includes, by the way, even consuming resources or gaining access to insensitive information. That can be also benign. Malignant is where there is a big damage that might happen from gaining this access. And to detect the intrusion, whether it's benign or malignant, or there's no attack at all, we have intrusion detection systems and intrusion prevention systems. We know the difference between the two, of course. Intrusion detection system relies on detecting the intrusion, but not necessarily providing any countermeasure to rectify the system, as a result of this attack. Doesn't work on any countermeasures. It may not even stop or block the attack. It's just that it notifies someone that there is an attack happening, and it's up to you to do whatever you want. Versus attack prevention systems, which work on providing automated countermeasures to correct or to rectify the system while the attack is happening in real time. Okay? So all types of masala restrictions that the system can provide, it may in fact control the level of access based on whether there is an event happening or not. And this happens, for example, for us when we try to access certain service inside queue. It happened to me. I don't know if it happened to you before. But all of a sudden I get notification that my account has been blocked. Right? Of course, I can always access my ID.qu and I can get my account unblocked again through my phone and so on and so forth. But there is in some cases, by the way, I didn't do anything. It's just that the system detected that there is some kind of a suspicious behavior happening, and it blocked my ID just for safety. So that's why these IDS systems might, in fact, have false alarms. And we'll talk about scenarios where false alarms become really common, because there is some kind of a probability whether there is a suspicious behavior or not. There is the concept of CERT. CERT is a computer emergency response team. This is the other method corresponding to IDS and IPS. So instead of using IPS and IDS, we can have on-site personnel. These are people with some expertise that they collect information so they can be dispatched or deployed into the system. They go manually through the different parts of the system. They collect information. And then they routinely provide some CERT reports, they call them, CERT reports. These reports provide some information about the existing vulnerabilities in the system or the potential vulnerabilities of the system. Okay? These reports might get accessed by the attackers, by the hackers, in which case they can utilize these reports to, in fact, use these potential vulnerabilities to compromise the system. And that's why it's also good to also work on countermeasures after producing these reports. Is that the idea is to try to close all the gaps and close all the vulnerabilities. It is important for system administrators to quickly insert all software patches to close all these vulnerabilities. Okay? So this CERT team, they regularly provide some reports which highlights all the potential vulnerabilities and all the gaps in the system, and it's up to the system administrators to also work on countermeasures or work on patches and things like that to try to close these gaps. So criminal hackers, these are organized group of hackers, usually have specific targets in mind, whether it's financial gain or to blackmail certain, and this can be in the level of nations sometimes, level of countries, as we all know that even these types of criminal or systematic groups, they are being actually currently used by countries or by government to attack, to perform cyber attacks to other countries as well. Once a site is penetrated, the attacker acts quickly, scoping up as much valuable information as possible. So the idea is to perform some attack tree with certain actions that allows you to compromise certain part of the network. You collect as much information as you can, use this information to compromise another part, gain more information, and then you continue gaining grounds as you go through the attack. So IDS and IPS can be used for these types of attackers, but may be less effective because of the quick in and out nature. So if the attacker is especially IDS, because IDS does not have any systematic or automated procedure to do any countermeasures to block or to do anything like this. Okay? IPS may in fact be a little bit faster, but again, you may actually block certain access and it ends up being based on false alarm. So you block certain users from having a legitimate access because of some suspicion. And we have seen this many times. So it's a trade-off, really. That's why you need to really address this trade-off between, gaining critical information and also making the service available to users. It's actually a very, very difficult job to really strike a balance to address this trade-off. And it depends طبعا on the sensitivity of the business. If we're talking about banking, different from talking about academic institution like this, different from talking about stock market, things like that. So each of these types of systems, they have different criticality. So the insider attack, as we said, is usually hard to deal with because these are otherwise legitimate users. But amongst the most difficult to detect and prevent, it can be motivated by revenge or simply a feeling of entitlement. يعني ربنا ما يكتبها لحد يعني بس especially outside يعني foreign countries, if they terminate the job for a person, alhamdulillah it didn't happen to me يعني but it happened to some people I know. They usually call them from their offices for a meeting. It's actually very scary يعني. They call them from their offices. And then while they are being called from their offices, everything in their offices is blocked, physical and digital. All his access is provoked, is blocked, and even the access to the physical office, he never goes back to the office. They are being called on a meeting, you are being terminated, please do not go back to your office, you have to go from here home.
Security guy do it.
Yes. And the security guys, they take them outside the organization and they never have access back to their, and even all their digital, equipment and the hard disk and everything is mirrored and is imaged before they do this. So there is a certain procedure. It's actually a standard procedure. So it's a standard procedure to avoid, because if he's a legitimate user and we give him even 1 minute access, he may actually go back and perform different damage. He can access مثلا password database and he can remove it, or some credit card database and he can have access to it, things like that. So that's why for especially insiders and legitimate users, you have to deal with them very carefully. So for countermeasures, you enforce the least privilege, only allowing access, and that's why some people, they hate this, but ITS, they give only user access to students on laptops owned by the universities. Okay, and sometimes this is very frustrating. It happened to me, مثلا. I have user access on some of the laptops, and whenever I want to even install a simple software, I can't, which is very frustrating, but that's the way it is. So this is one countermeasure that they need to block or to limit the access to certain assets. Set logs to see what users access and what commands they are entering. And this is one of the most important tools which are used for IDS systems, is to log all the activities. This is the first and most important task that needs to be done. Protect certain resources with strong authentication, so two-factor authentication, of course. You don't have it, but we have it. So whenever we want to access Blackboard, for example, it's very frustrating. We have to receive a code and we have to enter it every time. So for them, Blackboard is very, very sensitive. Upon termination, we delete employees' computer and network access. And we mirror all the digital assets that he or she might have, so that they cannot claim ownership after they leave the organization. They cannot claim ownership of this piece of code, well, this IP, okay, and use it in a different organizations. Okay, so we have evidence that this is owned by the organization. So intrusion techniques, the objective of intruder is to gain access to the system or to increase the range of privileges accessible on a system, of course. And most initial attacks use system or software vulnerabilities that allow a user to execute a code that opens backdoor into the system. So the ways to protect, مثلا, the password file, we talked about this before. One method is to use اللي هو one way functioning اللي هو الهاش code يعني. So instead of dealing with plain text passwords, we don't actually store the passwords. We don't store the password as plain text, and we don't even encrypt them. We actually use a hash. Why? Because hashing is one way, okay, so you can never reverse it, almost never يعني. It's very يعني computationally infeasible to reverse it and know the actual password. So you store the password as a hash value, and we will see at the end of this chapter there is certain method to do this. It's not just simply hashing, but there is some extra things that need to be done. The system stores only the value of the function based on the user's password. The access control, access to the password file is limited. So we can store passwords as, of course, this is very uncommon now, but we store the passwords as plain text, but we have very, very limited access and limited privilege to this particular file. Of course, this is يعني not commonly used now. Yeah. So this is the most common method that's used to store the passwords. So the intrusion detection, اللي هو IDS system, is a system's second line of defense and is based on the assumption that the behavior of the intruder differs from that of the legitimate user. So we assume that the behavior of the intruder is different from the legitimate user, and it can be distinguished, okay, deterministically. This assumption, by the way, is not 100% true. In many cases, when you look at the different actions of the intruder, it might look with the naked eye or to someone who's not expert, it might look okay. Okay? But in fact, when you correlate all these events, it requires some expertise to see that these sequential actions like this, they lead to an attack. Which potentially means that there is some kind of overlap between the legitimate user behavior and the intruder behavior. There is some kind of overlap. And that's why this kind of overlap creates some false alarms. This leads to some false alarms, and we'll see that. So if an intrusion is detected quickly enough, the intruder can be identified and ejected from the system before any damage is done. Intrusion detection enables the collection of information about intrusion techniques that can be used to strengthen the intrusion prevention facility. So the idea is to collect information and then use these logs, or we call them audit logs, to analyze them and then come up with a conclusion that there is some kind of suspicious behavior. But we have to keep in mind that raising this flag might have a certain level of false alarms. Okay? So acting as a result of this suspicious behavior is also a question mark, because you can take some certain countermeasure and then it ends up being a false alarm. So you have blocked a legitimate user from accessing the system even though this user did not do anything suspicious. And it happened to me many times. I do normal service and all of a sudden I see that my account was blocked. So alhamdulillah, دلوقتي we have this يعني myid.qu, this is a lifesaver. So I connect to this my ID and then it sends me a code on the cell phone, and then I enter the code and then it unblocks my account. So this is a lifesaver. Before, we used to يعني call ITS and we used to wait days until our we used to wait days until our accounts are restored again. So now, alhamdulillah, it's a convenient service. Yeah, so this is the chart that shows that this is the distribution of the behavior of the intruder. And this is the distribution of the legitimate user. So there is some kind of overlap, and this overlap is natural. Okay? So the idea here is that detecting the intrusion is a probabilistic function. It's not something deterministic, which means that it's not 0 and 1. It has certain distribution. So you may actually decide that this is that there is an intrusion, and it ends up in this area, and in fact, that's a legitimate user, right? So this area in particular causes some kind of false alarms. So the main idea is how to really design a classifier that detects this area with very, very high probability. Okay? And this becomes a big question mark. This area becomes a big question mark. If you have a 50-50 probability, what do you do? If you have a 60% probability, what do you do? Should you act upon it? Should you block the access? So that's why it's a tricky call. It's not easy. Okay? But our main job is to try to really design a classifier which can detect this area with accuracy 100%, ideally. At least this area, we should not have any confusion, right? Here is when we have confusion, and we will always have false alarms. So now what are the different approaches for these intrusion detection systems? So we have two major classes of methods for IDS. We have the statistical anomaly detection, and we have rule-based anomaly detection. Okay? Rule-based anomaly detection talks about the fact that we will, ممكن حتى we can draw them initially. The idea here is that for statistical method, what we do is that we take some audit records, like historical audit records. We take the historical audit records. We perform some analysis, okay? And we come up usually with a set of مثلا statistics. These are in a form of مثلا some features, okay? And then we design certain algorithm based on these statistics or features, right? And these algorithms are using by machine learning or any kind of expert system. So we design that algorithm, and then what we do is that this is offline usually. Okay? Online we take certain audit record or set of audit records. We apply this algorithm, okay? And then if the algorithm says this is alert or no alert. If no alert, then we go back and so on. If there is an alert, either we take the action right away, or we sometimes use some kind of an alert count or some kind of flag. So alert count, and we raise this alert count, okay? So if that repeats again, then we raise this alert count until it becomes at a certain threshold, and then we say it's an attack. So this special path is when the alert count is just 1. So by detecting one suspicious behavior, we raise the flag and we say that this is an attack. Or we can work on certain repeated action. If it reaches up to a certain threshold, then we say that there is an attack. So that's how the statistical anomaly detection works. Rule-based is based on certain rules. Okay? So the rule-based is based, so if the attacker has مثلا this privilege, and the attacker or this user tries to gain access to a particular file on the system, and this file has these attributes, and, so there is certain criteria. If this criteria is met, then we say that this is a suspicious behavior. So there is rule, and we apply the rule. So again, we take the audit record, we apply the rule. So if the answer is yes, the rule is matching, then this is an alert. If not, then we go and take the other audit record, and that's it. ماشي? Sometimes though we can have a combination that these rules, how do you actually come up with these rules? Sometimes these rules is based on analyzing also the offline audit records. So you analyze the audit records and come up with certain rule base. Okay? And from these rule base, you can apply this algorithm. Or these rules may be designed by an expert or a system administrator manually. ماشي? But in many cases, these rules are also created as a result of analyzing the historical audit records of the system. But unlike this method where the algorithm might be complex, it might be like based on machine learning or expert system or something like this, the rule base is based on a matching against certain rules. That's it. واضح الديفرنس؟ طيب. As I said here, the statistical anomaly detection can be subdivided into what we call threshold detection or profile-based. Threshold detection here talks about the fact that you have to detect certain events and then increment a counter based on repeating that event. And this event, by the way, might happen by different users. So if a group of users try to log on using certain method, that will create an alert. Or if the same person tries to log on, مثلا with failure 3 times, then I block that user. Okay? If مثلا I find a credit card transaction from Amr, one initiated from the US and one initiated from Qatar. Okay? That goes into the same account. And this is initiated from different users. Then I block the account. Sometimes I get some of my credit card actually blocked because of some suspicious behavior. And so even in that cases, by the way, sometimes it's legitimate. Like I have my daughter مثلا in the US performing مثلا using my credit card. And I'm using my credit card in Doha. That's not, but for the bank, that's suspicious behavior. See how complex it is? And sometimes I get my credit card blocked and I have to go to the bank and replace it, even though I didn't do anything wrong. But for them, this behavior, so again, this is an example of how a legitimate behavior might sound overlapping with a suspicious behavior. But you have to take certain call, right? That this is a suspicious behavior, خلاص, I have to take certain action. Okay? And profile-based here talks about profile activities, but this is attached to a particular user. So we correlate all the events performed by a certain user. All the activities done by a certain user. So a user tries to log in here, and then he went to this host. He tried to change some attributes of a file, and he went to this host. He tries to access this database. He went to this host. He tries to do this. So you actually track the activities done by the same user on different locations of the system. So you have to group all the audit records related to a particular user and try to correlate all of them together. Okay? But again, as we said, the attack might happen by a group of users. It doesn't necessarily and always happen by a certain user. ماشي. So there is the threshold detection, which detects the same event happening even by different users, or the profile based, which tries to correlate all the events done by the different events done by the same user. Or the rule based, as we said, which involves the attempt to define a set of rules. And these rules, as we said, might actually be based on analyzing the historical audit records of the system. Okay. Type. The audit records, these are the first tool and the most important tool that we use for IDS systems. These audit records, they are classified into two types. Native audit records, and these native audit records, these are virtually all the multi-user operating system includes accounting software. These are not necessarily designed for intrusion detection. These are the normal logging of the system. Okay? Because for IDS, you may have to design specific audit records for IDS. Because the normal logging of the system may not have all the information that you need. For example, correlating and grouping مثلا audit records for a certain user, or correlating all the events of the same type, things like that. So the normal logging of the system tries to systematically record all the events, but there is no way for you to correlate things or to analyze them for IDS. So that may make so you can still use IDS methods on these types of logging, but you have to do extra work. But detection-specific audit records, these are designed with IDS methods in mind. So this actually makes the IDS or the detection process much more efficient. But this requires special design for these audit records. So you have to have a way, it's a complicated database, you have to have a way of grouping all audit records for a specific user, or grouping all audit records for a specific مثلا based on certain event, things like that. Okay? So the disadvantage is that this is extra overhead, of course, because you have to have different methods to create these audit records to simplify the detection, right? But the advantage here is that this leads usually to more efficient detection techniques. ماشي كده؟ طيب, for statistical anomaly detection, as we said, we have the threshold detection and the profile base. The threshold detection involves counting the number of occurrences of a specific event type over an interval of time. The easiest thing is that if a user tries to log in مثلا 3 times over a short period of time, okay, I will stop it. I will يعني raise an alarm and I will stop this access. ماشي? Even if it's done by multiple users in a short period of time, to the same account مثلا, or to different parts of the system, or things like that. So the idea is that we as we said, as an online, we take the audit record, we take the current audit record, and then we apply the algorithm. اللي هو algorithm, which is a result of analyzing the historical audit records and providing some features and designing some expert system to come up with this algorithm. And if there is certain event, then we increment some occurrence. And if there is a limit, if that's yes, طبعا. If it reaches a limit, for example, 3 times, then we say alert. Otherwise, خلاص, we go to the second audit record, and we go through this process again. This algorithm, as we said, is a result of an offline process back, where we analyze the historical audit records and so on. ماشي? Profile-based focuses on characterizing the past behavior of individual users. Okay? So this based on grouping the audit records for one user and then applying the algorithm for these audit records belonging to one individual users. A profile may consist of a set of parameters so that deviation on just a single parameter may not be sufficient in itself. So these audit records might actually be different actions at different levels of the network. It might actually be connecting to a modem or connecting to an access point and then uses a particular application to use HTTPS, مثلا, and so on. So these actions in this sequence provided by one single user might in fact be raised as an alarm or a suspicious behavior or something like this.
Happened to me once when I was like doing the workshop. I was trying to access the website to buy tickets, me and my brother. So we were just like trying to access the website every 10 minutes, and they ended up blocking our IP address at the house, and we couldn't access the website.
So you and your family members, you were trying to from the same IP address لأنكم طبعا.
Yeah, they blocked the IP address, and then we had to like use VPN to access the website to buy the tickets.
Yeah. Sometimes they block the access for a certain period of time and then they restore the access, and sometimes they block it permanently. So this is the type of countermeasures, which is again, it's a tricky thing. The rule base, as we said, rule base is similar in terms of approach and strength. Well, you may actually agree or disagree with this because statistical anomaly detection usually includes machine learning techniques, which now is getting more sophisticated, and with machine learning, we have been able to reach to good level of accuracy for the detection. Rule base is based on applying certain rule base, and sometimes this is primitive compared to analyzing the statistical behavior using machine learning, which usually leads to better accuracy. But this is maybe based on old information. So historical audit records are analyzed to identify usage patterns to automatically generate this rule base. So again, they are similar in the sense that, similar to the fact that you analyze offline the audit records to come up with features and then design an algorithm for statistical anomaly detection. Here, you may actually use the same method but come up with a rule base. Rule base is عبارة عن إيه؟ A lookup table of certain rules that when you see an audit record, you apply all these rules on the audit record. If one of them matches, then خلاص. Okay? So in order for this approach to be effective, rather large database of rules needs to be. And this is the efficiency and the strength of machine learning, because you don't have to base your approach on a very large lookup table, because this will even be very complex. If you have مثلا تخيل انت if you have مثلا 100,000 rules in the rule base, you have to apply these 100,000 rules on every single audit record. Okay, with machine learning, it's a simple مثلا multiplication. But the idea is that you have to do the online analysis carefully and come up with the algorithm, and the algorithm is based on machine learning. So you apply the features of the audit record on the machine learning algorithm, and the answer is very fast. Okay, so that's the advantage here.
Today we have two seminars.
Okay, I know what you're. Okay, طيب ماشي. Yeah, I was hoping.